Let's solve paper 1-2 for May-June 2022 in this video. So let's start with question number 1, part A, work out 2 over 3 plus 1 over 6. So if I take the LCM, it will be 6. 3 is multiplied by 2 in the denominator. So in the numerator, I will multiply this 2 by 2 as well, and then plus 1. So 4 plus 1 over 6, it is equals to 5 over 6. Part B, 0.4 multiplied by 0.2. So I like to convert them into fractions to make the multiplication easier and more clear. So zero point 0.4 will be 4 over 10. 0.2 will be 2 over 10. So this will be 8 over 100, which is 0.08. I move the decimal 2 times to the left to divide by 100. So 0.08 will be your final answer. Question number 2, Asha asks a group of students about their favorite fruit. The table and pictogram shows some of the results. So you have fruit and frequency. So 8 people said that their favorite fruit was apple, 5 said orange, and so on. Part A, complete the table and pictogram. In this pictogram, each circle represents 4 people. So for banana, this is 4, this is 4, and this is 4. So 4 times 3, the frequency is 12. For melon, this full circle is 4, and this circle here is 3 by 4, right? It is 3/4 of a circle, not a full circle. So full circle represents 4, and this will represent 3/4 of 4, which is 3 by 4 multiplied by 4. 4 and 4 cancel out, so this is 3. So this here represents 3. 4 plus 3, the total frequency for melon will be 7. And now we have to complete this pictogram. So for apple, how many circles we will have? Your frequency is 8, so number of circles will be frequency divided by 4. So for apples, your frequency is 8, and then divide by 4, you get 2 circles. So apple will have 2 circles. And for orange, you'll do the same. Your frequency is 5, and then divide by 4. Now since 5 is not divisible by 4, I will have to split this up into a full circle, and similar to what we have here. So if I write this improper fraction as a mixed number, I will have 1 whole 1 over 4, right? If I convert this back into this fraction, 4 times 1 is 4, plus 1, 5 over 4. So that means I have one full circle, and the other one is 1/4 of a circle. So 1/4 of a circle will look something like this. I will draw a quarter of a circle like this. So this will represent 4 people, and this represents 1 person. So 4 plus 1 will give you the frequency 5 for oranges. Part B is write down the mod. So mod will be the highest fruit with the highest frequency, which is banana, frequency 12. So banana will be your mod. Question number 3. A and B are vertices of a quadrilateral. Line L is the line of symmetry of that quadrilateral. Find the coordinates of the other 2 vertices of the quadrilateral. So this is the line of symmetry. That means both of these vertices will have a mirror image on the other side of the line of symmetry. So you basically have to reflect these vertices across this line L to get the other 2 vertices. So to find the mirror image, I'll connect my point A with the shortest distance to my line of symmetry, which will be this distance. If you're not sure, you can use a set square here as well. So you know that this angle here of a set square is a 90-degree angle. So if I connect this using my set square, I get to this point, and this angle here will be 90-degree. That means this is the shortest distance of A from my line of symmetry. And to do the reflection, I will continue the same distance on the other side of my line of symmetry to get the mirror image. So I will end up here at this point. So let's call this A prime, which is the reflection of A across this line of symmetry. And repeat the same process for B. Again, a line connecting B to line of symmetry where this angle is again 90 degree, and then same length of line on the other side to get to you this point. So you crossed half a block here and then you crossed the other half here. So these two lines are they have the same length. So this will give you B prime. So these two will be your vertices on the other side of line of symmetry, and this will, all these four form this quadrilateral. So what are the coordinates? A prime is 3 and 4 and B prime is 4 and 2. Question number 4, part A. The temperature inside Luke house is 18, outside his house is -3. Find the difference. So the difference will be the larger value minus the smaller value. Larger is 18 minus the smaller value is -3. Minus and minus will become positive. So 18 plus 3, 21. So the difference is 21 degrees Celsius. Luke's thermometer measures temperature correct to the nearest degree. That means correct to the nearest 1 degree Celsius. And to find the error, you divide, error is degree of accuracy divided by 2. So degree of accuracy is 1 divided by 2, which is 0.5. At midnight, the thermometer measures outside temperature as -6 degrees Celsius. Find the upper bound of the temperature outside at midnight. So upper bound will be the temperature measured plus the error, because you're trying to find the upper bound. Measured temperature is -6, error is 0.5. So -6 plus 0.5 will be minus 5.5 degree. So this will be minus 5.5 degrees Celsius, the upper bound of temperature outside at midnight. 5. The scale drawing shows positions of two villages A and B. The scale is 1 centimeter to 2 kilometer. Find the actual distance between village A and village B. So first we'll measure the distance in centimeter and then convert it into kilometers using the scale given. So let me draw a straight line between point A and B and measure that. So this is 9.3 centimeters. So this line here is 9.3 centimeters. So the scale is 1 centimeter is 2 kilometers. So 9.3 centimeters will be 9.3 multiplied by 2, which is 18.6 kilometers. So this is the actual distance between the two villages. Part B is measure the bearing of B from A. So to measure the bearing of B from A, I need to measure this angle here. So this is from the north of A up till B. So I'll use my protractor here, center it at point A, like this. And so this is 180. So my zero is starting from here. 10, 20, 30, 40, 50, 60, 70. So up till 110, this is 70 degrees up till 110. And then I have to go 1, 2, 3, 3 more. So this is almost 73 degree. So this angle here is 73 degree. So your bearing of B from A will be 0.73 degrees. Question number 6. Kabir invests $250 in a savings account. The account pays simple interest at a rate of 1.5% per year. Calculate the total amount of interest he will receive at the end of 4 years. So you know the formula for simple interest is principal times rate multiplied by the time duration divided by 100. So let's substitute the values here. Principal amount is 250 multiplied, your rate is 1.5 multiplied by the time for which he is investing, which is 4 years. divided by 100. So 4 times 1.5 is 6. So 250 multiplied by 6 over 100. 250 times 6 would be 254 is 1000, 1500 divided by 100, and this is 15. So your interest for 4 years at the end of 4 years is $15. Question number 7. The area of this rectangle is 9 centimeter square. Area of triangle is 85 millimeter square. Calculate the shaded area. Give your answer in centimeter square. So your shaded area is rectangle area minus this triangle. So rectangle area minus the triangle area. So what is the area of rectangle? It is 9 centimeter square, and you want your answer in centimeter square as well. So I will write this down. 9 minus the triangle area is 85 millimeter square. So now we need to convert this into centimeter square. So 85 millimeter square will be 85. So 1 centimeter is 10 millimeter. But since this is square, it is area, so I will take 10 square as well. So 1 centimeter is 10 millimeter, and 1 centimeter square will be 10 square millimeter square. So this will be 85 divided by 100, which is equals to 0.85 centimeter square. So this will be 9 minus 0.85. So 9 minus zero point 0.8 is 8.2 and 0.85. So this will be 8.15 centimeter square, this which is the shaded area. Question number 8. The diagram shows a pentagon. Find the value of A. So A is this angle. You're given the rest of the angles. So first, let's find sum of all angles of a pentagon. So you know the formula is n minus 2 into 180. This gives you the sum of all interior angles of any quadrilateral where n is the number of sides. So pentagon has 5 sides. So 5 minus 2 into 180. This will be 3 times 180. So this will be 0, 8 3s are 24, 2 carry 540 degrees. So sum of all these angles is 540. So now let's find the value of A. A plus 95 plus 110 plus 125 plus 65 is 540 degrees. So 110 plus 90 is 200, 205, 305 plus 25 will be 330, 330 plus 65 will be 395. So A plus 395 is 540. So A will be 540 minus 395. So this is 145. 145. Question number 9. Shani makes a sequence of patterns using these counters. So you have to complete the table. Pattern number 1 has 5 counters. Pattern number 2 has 8. Pattern number 3 has 11. So if you look at the next pattern, every time you're adding 3 counters to get the number of counters in the next pattern. So 11 plus 3 will be 14. 14 plus 3 will be 17. Find an expression in terms of n for the number of counters in pattern n. So if I have pattern and number of counters. So if you look at from the start, pattern number 1 has 5 counters. Pattern number 2 has 5 plus 3. So 5 plus 3, which is 8. Pattern number 3 has 5 plus 3 and then another 3 to get to 11. Pattern number 4 has 5 plus 3 and then another 3. So each time you're adding 3. So if you look at this pattern here, how many 3's do you add? Each time If pattern number is 3, you are adding 2 threes. If pattern number is 4, you are adding 3 threes. If pattern number is 2, you are adding 1 3. So the number of threes that you add is 1 less than the pattern number, right? Each time. Pattern number 2, you added 3 once. Pattern number 3, you added 3 twice. So whatever the pattern number, you add 1 less number of threes. So if pattern number is n, number of counters will be 5 plus how many threes? N minus 1, right? Because this is equals to 5 plus 3 into 1. This is equal to 5 plus 3 into 2. This is equals to 5 plus 3 into 3. So this number here each time is 1 less than the pattern number. So if this is n, this will be n minus 1. So now let's solve 5 plus 3n. If I open the bracket, 3n minus 3. And 5 minus 3 is 2, so this will become 3n plus 2. So number of counters in pattern number n is 3n plus 2. Part C, Shani has 100 counters. She uses some of the counters to make pattern 20, and then she uses all the remaining counters to make pattern K. Find the value of K. So first, she uses some of the counters to make pattern 20. So we need to find out how many counters were used to make this pattern and how many were left over, that all the remaining ones that she used to make pattern K. So let's first find out how many counters are used to make pattern 20. So number of counters in pattern 20 will be, so you know the formula, 3n plus 2. So n is what? 20 now. So 3 into 20 plus 2. So this is 60 plus 2, which is 62. So now how many are remaining? Remaining counters. She started with 100. She used 62 to make pattern number 20. So leftovers are 100 minus 62, which is 38. So now she uses all of them. That means all 38 were used to make pattern K. So we know already the formula. Number of counters for pattern K will be, in place of n, I'll simply write K. For pattern K, I have 3K plus 2. And how many counters were used? 38. Because we are told she used all the remaining. So remaining were 38 and all were used. So 38 equals to 3K plus 2. And now we can find pattern number K. If I bring this 2 here, this will become 36 equals to 3K. And this gives me K equals to 12. So pattern K is pattern number 12 because K, your value of K is 12 here. Question number 10. A bag contains red balls, blue balls, and green balls. Red ratio blue is 3 ratio 8, and green ratio blue is 2 ratio 5. So you have red ratio blue. So let me write it down. Red ratio blue. Blue is 8 and red is 3. And then you have green ratio blue. So green ratio blue. Green is what? 2, and then blue is what? 5. In fact, let me write it down the opposite way so that we can see the common value is blue here. So blue ratio green. Blue ratio green will be 5 ratio 2 from this. So green is 2. So we don't know what is the ratio of red ratio green, right? Blue is the common ratio that we are given. So we have to work out the fraction of the balls that are blue. So first we need to find red ratio blue ratio green, whatever these are, and then we can find the fraction that are blue. The total, we can calculate the total through the ratios, add all the ratios, you get the total, and use the value for blue to calculate the fraction of balls that are blue. So to calculate this, we are given here blue as the common ratio because we are given blue ratio red as well as uh, blue ratio green. So this is the blue is the common one which we can use to basically find the ratio of red ratio green. So if I can make these two numbers similar, I can write this as red ratio blue ratio green if blue is same here as well as here. So that means calculating the LCM. So 8 and 5, the LCM will be 40, 8 times 5 because they do not have any common factors. So I'm multiplying this by 5. That means I need to multiply this by 5 as well. And this is being multiplied by 8. So this will be multiplied by 8 as well. So let me rewrite these ratios now. So 5 times 3 is 15. Ratio 8 times 5 is 40. And then 8 times 5 is 40 with 8 times 2 is 16. Now this is 40 as well as this is 40. So this is now the same ratio. So I can write this as a single ratio now where my red is 15, red ratio blue ratio green. Now 15 ratio 40 and then green is 40 ratio uh, 16. So now I have all three red, blue and green. I have all the three ratios together. So that means if you have 15 red balls in the bag, you will have 40 blue balls and 16 green balls because they are in ratio 15, ratio 40, ratio 16. So now you want to calculate fraction of blue. Fraction of blue balls. How many are blue? 40 out of the total 15 plus 40 plus 16. 15 plus 40 plus 16. So 40 divided by 40, 50, 60, 65, 71. So that means the fraction of blue balls is 40 over 71. So this will be your final answer, 40 over 71. Question number 11, part A. Use a straight edge and compass only to construct the bisector of angle PSR. So this is your angle PSR, and then you have to construct the angle bisector. So I'll use my compass here, center it at point S, and then draw the arc from the two lines that make the angle, in this case SR and PS. So this will be my arc. Then place your compass where the arc intersects with the line SR, like this. And then we'll draw another arc here. Then place the compass on the other line where the arc intersects PS, and we'll draw another arc here. So now I will connect my point S with the intersection of this arc and this arc, which is this point. So not this arc. I'm only looking for intersection of this and this, which is this point here. So I'll draw a straight line from S passing through this intersection. So this will be my angle bisector of angle PSR. Part B is point X lies inside the quadrilateral PQRS and is closer to PS than to RS. Shade the region in which X must lie. So it's inside the quadrilateral. and it's closer to PS, this line here, versus this line RS. So that means it's on the somewhere on the left side of this angle bisector, because this region, all this region is closer to PS than to RS, and we have to remain inside the quadrilateral. So this will be your shaded region in which your point X can lie. All this region towards the left side of your angle bisector, but staying within the quadrilateral because point X is inside. So this will be your region in which your point X can lie. Question 12, part A. Write this number correct to three significant figures. So if we start from the left side, the first non-zero number is this. So we will start counting the significant figures from 2. So we need up till 3 significant figures. So 1, 2, 3. So this is the third significant figure. The next value is 5. So that means this will be rounded up to 4. So your answer will be 0.00204. Part B, by writing each number correct to one significant figure, estimate the value of this. So again, this is first significant figure, next value is 9, so this will be rounded up to 4, multiplied by, this is the first number, first significant figure, next value is 3, so this will be written as, so this will be rounded down to 60, divided by, this is your first significant figure, 4, next value is 2, so this will be written as it is as 0.4. Square root of 4 is 2, multiplied by 60 divided by 0.4, which is 120 divided by 0.4. And if I remove this decimal, multiplied by 10 in the numerator, so numerator becomes 1200, denominator becomes 4, 4 ones are 4, 4 threes are 12, and the 2 zeros. So 300 will be your final answer. Question 13, part A, evaluate this. So square root of 9 will be 3, multiplied by cube root of 64 will be 4. 4 times 4 is 16, and then 16 times 4 is 64. So the cube root here will be 4, and then the square as it is. 4 threes are 12 square, which is 144. So your answer here is 144. You might wonder here why I did not take -3, because square root of 9 could be -3 as well, right? But it won't matter because we take the square afterwards, so your answer will be positive anyways. And for cube root, since 64 is positive, so the cube root is positive as well. You cannot have -4 as the cube root of 64, because -4 times -4 times -4 will be -64, but you have positive 64 here. So this is positive 4, and this is, I've taken positive 3, but it doesn't matter if I take -3 as well. It will turn out to be, your answer will be the same, because at the end you take the square. Part B is write down an irrational value of n that satisfies this inequality. So irrational value or irrational number is a number that cannot be represented as a fraction. So usually we take numbers that are not perfect squares. If you take the square root, you get an irrational number. So your n lies between 4.5 and 5.5. So if I take 4.5 square, because I want to take a square root number, but the square root number, square root of something, let's say it cannot be 25, because square root of 25 is 5, so that's not an irrational number. But I need a square root of a number which is not a perfect square, such that the square root value will fall between these two values. So for that I'm trying to find my lower range. Lower range will be 4.5 square. So 5 fives are 25, 2 carry, 5 fours are 20, 22, multiply sign here, 5 fours are 20, 2 carry 16, 18. 5 to 10 1 20 20.25. So if I take 4.5 square, I get 20.25. That means I have to take a square root of number that is larger than 20.25. So it could be 21, it could be 22, it could be 23, it could be 24. It cannot be 25 because that is a rational number. Square root of 25 is 5. 25 is a perfect square number. So I can choose any of these numbers. If I take the square root of any of these, the square root value will be greater than 4.5 but less than 5 because square root of 25 is 5. So it will, if it's less than 5, then it's definitely less than 5.5 as well. So any of these square roots will give you an irrational number in this range that is required. So I'll just take here square root of 21. 14 part A, write down these numbers in order of size. So let me write down these two numbers as decimal as well. So 2 into 10 power minus 4 means I have to move decimal 4 places to the left. 1, 2, 3, and then 4. So that means 0.0002, and this will be 0.12, 0.02, and this is 2000 as it is, and this is 0.002 as it is. So the smallest number, now I can like compare them directly. Smallest number is this one here, 0.0002, which is actually 2 into 10 power minus 4. So this is your smallest number. The next smallest number is this, which is 0.002. The next larger number is this, 0.02, which is 2 into 10 power minus 2, and then the largest number is 2000. Part B, this is a calculation using numbers in standard form. You're given this equation. Find the value of A and value of B. So let me write this down as a fraction because this is a division sign. So I will get A into 10 power minus 7 divided by 5 into 10 power B equals to 4 into 10 power minus 16. So I'll take this to the other side so that I can find the value of A. So A into 10 power minus 7 will be 5 times 4 is 20 multiplied by, so this is being multiplied here, so these powers of 10 will add. So 10 power minus 16 and then this plus B. Now remember, you are told that this here is in standard form. So I cannot right now say that A equals to 20 because this is not in standard form. For standard form, your value is, so let's call that value x. It is greater than equal to 1 but less than 10. So whatever numbers you have with 10 power, the number here will always be in this range. So this is not in this range. You are told that this equation is in standard form, so A must lie in this range. So to bring this into this range, I can move my decimal from 20 to make it 2. I can move this decimal one place to the left. That means I have to increase my power of 10 by 1. When you move the decimal to left, you increase the power by 1. So A into 10 power minus 7. I move the decimal to the left, I get 2 into 10 power minus 16 plus B and plus 1. Now I can compare them because this value is in standard form now. So your value of A, because you have 10 power here, 10 power here, so you can directly compare these two values. So your value of A is 2, and then I can, since the base is same, you have 10 power minus 7 here and 10 power this. Bases are same, I can equate the powers. So let's equate the powers. Minus 7 equals to minus 16 plus B plus 1, and then find the value of B. Minus 7 equals to minus 16 plus 1 is minus 15 plus B, and then this will give you B equals to minus 7, and then take this 15 to the other side, plus 15. 15 minus 7 will be 8. So your value of A is 2, your value of B is 8. Question 15, y is directly proportional to this. So y is directly proportional to x minus 1 square. That means y equals to k times x minus 1 square. When x is 5, y is 32. So y is 32 when x is 5 minus 1 square. So 32 equals to k. 5 minus 1 is 4. 4 square is 16. And then k equals to 2. Take this 16 to the other side. It will be divided. 32 divided by 16 is 2. So your equation is y equals to 2 into x minus 1 square. Find y when x equals to minus 2. So let's substitute x equals to minus 2 here. Minus 2 minus 1 square. So y will be equal to minus 2 minus 1 is minus 3. 2 into minus 3 square. Minus 3 square is 9. 9 twos are 18. So your value of y is 18. Question number 16. The graph of y equals to x cube over 5 minus 3x plus 2 is drawn on the grid. By drawing a tangent, estimate the gradient of the curve at x equals to minus 1. So x equals to minus 1 is this point. I'll draw a tangent such that it will just touch the curve at x equals to minus 1 here. So let me try to draw the straight line or the tangent. So this will look something like this. Just touching the graph at x equals to minus 1. So now I can take any 2 points on this straight line to find the gradient. I can take this point, which is minus 2 and plus 7. So I've taken this point here, minus 2 and 7. Let's take another point here at 0. It's intersecting here 2, 2 point. So each small block is 0.2, 2, 2.2, 2.4, 2.6. So 0 and 2.6. So now I'll use these two to find my gradient. y2 minus y1, 7 minus 2.6 divided by x2 minus x1 minus 2 minus 0. 7 minus 2.6, 7 minus 2 is 5, and then 0.6, so 4.4 divided by minus 2. So this will become minus 2 twos are 4, 2 twos are 4. So minus 2.2 is your gradient. By drawing a suitable straight line on the graph, find the solutions of equation x cube over 5 minus 3x equals to 0. So if you look at this equation here, it looks pretty similar to this one. So I'll try to make one side of the equation exactly the same so that I can use my curve that is already given. So this equation is y, let me rewrite it here. So you're given y equals to x cube over 5 minus 3x plus 2 in the question here. And then you're given the graph as well. So now let me try to make this left side the same as this. So I have x cube over 5 minus 3x. I'm only missing this plus 2. So let me add plus 2 on the left side of the equation and plus 2 on the right side, right? So that means x cube over 5 minus 3x plus 2 equals to 2. So now I have this equation, y equals to, that is given here, which is this side here. So y equals to x cube over 5 minus 3x plus 2. And the other side I have y equals to 2. So if I try to solve them simultaneously, if I substitute y equals to 2 here and take it to the other side, 2 minus 2 will become 0 and I get the same equation back. That means if you try to solve these two simultaneously through elimination, if you eliminate variable y, you get this. But you're trying to solve them through the graphical method. How do you solve by graphical method? You find the points of intersections. You're already given this curve. is already given. So you only need to draw y equals to 2. So let's draw y equals to 2 here. Y equals to 2 will be this line. So it intersects at 3 points. One is here, which is almost minus 3.9. Here it is at 0. So this point here is 0. And this one here is, it's almost 3.9. It's in the middle, so let's call it 3.85. It's between 3.8 and 3.9. In fact, on this side as well, if you look closely, it's slightly in the middle. So this can be written as minus 3.85, but if you write it as minus 3.9, it is also an acceptable answer. So your three solutions are x equals to minus 3.85, x equals to 0, and the third solution is x equals to positive 3.85. Question number 17, part A. Ryan says each diagonal of a quadrilateral Q divides it into two congruent isosceles triangles. Draw a ring around each of the quadrilaterals in the list for which Ryan's statement is always true. So let's look at a square. It has all four sides equal. So diagonal, if you draw a diagonal, each diagonal of a quadrilateral divides it into two congruent isosceles triangles. So these two triangles, are they isosceles? Yes. This triangle has these two sides equal. This triangle has these two sides equal. Are they congruent? Yes. Because this length is this length. These two lengths are same as these two lengths, and this length is common, which is the diagonal. So they are congruent as well. So this statement is true for a square. We'll circle the square. Then let's look at a rectangle. So this side is equal to this side, and this side is equal to this side in a rectangle. And if I draw a diagonal, are these isosceles triangle? No, because this length and this length are not same. So this condition fails. You have to check two conditions: isosceles triangles, and both are congruent as well. But these are not isosceles triangle. No two of their sides are same. So if you look at this triangle, it has no two equal lengths. So this is not true. Let's draw a rhombus. Rhombus has all four sides equal, and if I draw a diagonal, isosceles triangle, yes, because these two sides are equal. On this side, also an isosceles triangle because these two sides are equal, and these two triangles are congruent as well. This length is same as this length is same as this length, and this is the common length. So all three sides are the same. So these two are congruent, so you'll circle rhombus. Parallelogram, again, similar to rectangle. This side equal, and this side equal. So the triangles are not isosceles. Two sides of a triangle are not same. So parallelogram is not true. Trapezium looks something like this. So again, this side is not equal to this side is not necessarily equal to this side. So you don't have isosceles triangle. This triangle is not isosceles. This triangle is not guaranteed to be isosceles. So this is not always true. Let's look at kite. For kite, if you draw this diagonal here, and you know that kite has these two sides equal and these two sides are equal. But this triangle and this triangle, are they isosceles? No, because all three lengths could be different. So you're not guaranteed that this triangle is isosceles or this triangle is isosceles. There is another possible diagonal as well for the kite. Let me draw that as well. So what if we draw this diagonal? Now this is an isosceles triangle. This is also an isosceles triangle. But are they congruent? No, because although they have this one length same, this length is not same as any of the other two lengths of this triangle, and this length is also different from this. So although they are isosceles triangles, they are not congruent. So this is not always true for a kite as well. So it's only true every time if you have a square or if you have a rhombus. The diagonals will create two triangles that are isosceles as well as congruent to each other. So the only two circles that you will draw will be for a square and a rhombus. B is AXB and CXD are straight lines. X is the midpoint of AB and AC is parallel to DB. Show that triangle AXC and triangle BXD are congruent. Give a reason for each statement you make. So if you look at these two triangles, this length is the same as this length because you're given X is a midpoint. These two angles are same because they are vertically opposite, and then these two lines are parallel, so that means this angle here and this angle here, so this angle and this angle will be same, and this angle and this angle will be same as well because they are alternate angles. So this angle is equals to this angle. Write it down here. So this is same as this, alternate angles. This is same as this because of alternate angles again and vertically opposite angles. And then this length is same as this length. So we can use the AAS property where you have two angles and one side same. So let me write it down. So this length AX equals to XB because X is midpoint. Then angle AXC, this angle here, is equals to this angle BXD because they are vertically opposite angles. And then this angle here, BDX, is equals to this angle here, ACX. In fact, let me write this ACX because I'm just writing this sides and angles of this triangle on the left side, so I'll just keep it consistent. So angle ACX is equals to angle BDX. Why? Because these two lines are parallel and these two are alternate angles. So you can say alternate angles. So you using AAS rule, triangle AXB is congruent to triangle CXD. Question number 18, you're given f of x, find f inverse of x. So you let y equals to f of x, and this gives you, if you take f to the other side, f inverse of y equals to x. So you'll make x the subject, so substitute f of x equals to y equals to 3x minus 7. Now make x the subject of the formula, take this 7 here, y plus 7 equals to 3x, and x equals to y plus 7 over 3, and x is what? F inverse of y. So f inverse of y is y plus 7 over 3. This means f inverse of x will be, simply substitute y with x plus 7 over 3. Question 19, part A. Your universal set consists of A, B, C, D, E, F, G, H, I, J. P is this, Q is this, R is this. Find P union Q. So P union Q will be all the elements in P and all the elements in Q but you don't have to write any element twice. So let me first write down all the elements of P. A, E, I, and then all the elements of Q, making sure I do not repeat any letter. So F, G, H, I have already written, so J. So this will be your P union Q will be A, E, I, F, G, H, and J. Find number of elements in this. So let's first find Q union R. Q union R means basically all the elements of Q and R without repeating. So let me write them down in alphabetical order. C is here, D, E, F, G. So this was all R. F I've already written, G I've already written, H, I, J. H, I, J. So this is Q union R. What is P complement? All the elements that are not in P. So A, E, I. All the elements except A, E, I, which are B, C is not here. So C, D, E, F, G, H. D, E, F, G, H. I is here. So I is not part of P complement. And then J. Now you have to find the intersection of these two because of this P complement intersection Q union R. And that means what are the common elements between the two, and you just have to give the number. You don't have to write all the elements. So C is common, D, E, F, G, H, and J. So 1, 2, 3, 4, 5. I think I made a mistake here. Q union R was C, D, E, F, G, H, I, J. So E is part of P. So this is not correct here. So E was here, Q union R, but E is not here, P complement, because E is part of P. So that was a mistake. Okay, so 1, 2, 3, 4, 5, 6. 6 elements are in this set of P complement intersection Q union R. Use set notation to describe the shaded subset in the Venn diagram. So shaded subset is an overlap of A and C. So you definitely have A intersection C in your set notation. So A intersection C is this whole area, right? But shaded area, you have excluded this. So this is part of B. So that means intersection B complement outside of B. So A intersection C will give you whole of this. And then to exclude this, you will add intersection B complement. That means everything outside of B, but within this blue area, which is denoted by A intersection C. So A intersection C intersection B complement gives you this shaded area. Question 20, A, B, C, D are points on a circle, center is O, find angle ADB. ADB is this angle. So it is subtended by this segment, and this segment also makes this angle at the center, which is 70 degrees. So you know that angle at center is twice the angle at circumference. So this angle will be half of this. So 70 divided by 2, 35. Angle BCD. So BCD is this. So now if I look at this, ABCD is a cyclic quadrilateral because all four vertices are at the circumference, right? So this angle is opposite to this angle. I know part of it is 25. If I can calculate this, this plus this should be 180 because sum of opposite angles of a cyclic quadrilateral is 180. So can I find this angle? Since this is the center, this is radius, so that means these two lengths are equal. So this angle will be equal to this angle. So OAB and ABO, these angles are equal. So let me call them Y. So Y plus 70 will be 180. 2Y will be 110 and Y will be 55. So this angle here is 55 degrees. Now I can use the property of cyclic quadrilateral, which is opposite angles. So angle DAB plus angle BCD equals to 180. DAB is 25 plus 55. 25 plus 55 plus BCD equals to 180 will be 180 minus 55 plus 25 is 70, 80 minus 80, which is 100. So angle BCD is 100 degree. Question 21, part A, factorize this. So you'll multiply the coefficient of x square, which is 4, with this number, which does not have x variable. So minus 6 times 4 is minus 24. So you're like looking for factors of 24, which if I subtract them, I should get this number, which is 5. Subtract because I have minus 24 here. So 8 and 3 are factors. 8 times 3 is 24. 8 minus 3 is 5. So 4x square plus 8x minus 3x minus 6. 4x common, x plus 2 minus 3 common, and x, this minus will become plus because I've taken minus outside, x plus 2. So 4x minus 3 into x plus 2. Part B is simplify this expression. So I'll take the power inside, it will be multiplied. 16 power 1 multiplied by minus 1 by 2. So I'll get 16 power minus 1 over 2 divided by x power 6 multiplied by minus 1 over 2. So 16 power minus 1 over 2 divided by 2 times 1, 2 times 3. So x power minus 3. To make the powers positive, I'll take this into the numerator, bring this into the denominator. So I'll get x cube over 16 power 1 over 2. And you know that power 1 over 2 is simply square root. So square root of 16 is 4. So your answer is x cube over 4. Question 22, a bag contains these 9 letter tiles. Part A, Noor takes one tile from bag at random. She notes the letter, then puts the tile back in the bag. Find the probability that she does not take a letter E. So probability that she does not get E is number of tiles that are not E divided by total tiles. So how many of tiles are not E? This is E, this is E as well. So how many are remaining? 1, 2, 3, 4, 5, 6, 7. 7 are not E out of the total 9. So your probability of getting a letter that is not E is 7 over 9. Part B is Noor now takes 2 of the 9 letter tiles at random without replacement. So that means when she takes out the first tile, she does not put it back when she's before taking out the second tile. So it's without replacement. Find the probability that both tiles show the same letter. So probability both have same letter. So how can I get two tiles with same letter? I have multiple S's, so I can get probability that the first one is S and second is also S. That way I'll have both tiles that show the same letter. Or there is another way that you can also get same letters, that is with E. So first is E and second is also E. That way you also end up with two tiles that have the same letter, which is E in this case. So when you have an AND, you multiply the probabilities, or means adding. So what is the probability? First is S, and probability second is S. These will be multiplied. So probability first is S multiplied probability second is S. Calculate this, or plus, and then you'll do the multiplication here as well. Probability that first tile is E multiplied by probability that second tile is E as well. So what is the probability that the first tile is S? When you're picking the first tile, how many S do you have? 1, 2, 3 out of the 9. And then you don't put this S back. So you can cancel any S out. You've taken one S out. Now what is the probability that the second is S? How many S are left? 1, 2. 2S out of the total 1, 2, 3, 4, 5, 6, 7, 8. So remaining tiles are 8 because you've already taken one out. So 2 over 8. Plus, now let's find the probability for E. Now you're taking the first tile. What is the probability that now you're back to start? First one is E. 2E, 2 E's out of the 9. So 2 over 9 multiplied by second E. Now you have one remaining E. 1 over how many total tiles remaining? Again, 1, 2, 3, 4, 5, 6, 7, 8. Total remaining are 8 when you're picking the second tile. So let's calculate this. This will be 6 over 9 eighths are 72 plus 2 over 9 eighths are 72, which is 8 over 72. Or if you want to simplify, 8 ones are 8, 8 nines are 72, 1 over 9. So your final answer here will be 1 over 9. Question number 23. The diagram shows a major sector of the circle, radius 3. Calculate the area of the sector and give your answer in this form. So if this angle is 80, this angle is 360 minus 80, which is 280 degree. So area of this sector will be 280 divided by 360 into pi into radius square, 3 square, which is 9. 9 ones are 9, 9 fours are 36, 0. 0 and 0 cancel out, 4 times 1, 4 times 7 is 28. So you're left with 7 pi centimeter square. Question 24, part A, you have to solve this. So let's take this denominator to the other side. 3 times 3 is 9x, plus 3 times 10 is 30. Bring this all x terms to one side. This will be minus 9x. Take this 2 to the other side. 30 minus 2. Minus 14x equals to 28. And x will be equal to minus 2. Part B expressed as a single fraction. So we'll take the LCM. X minus 2 multiplied by 2x plus 1. So this 3 will be multiplied by 2x plus 1. Minus 5 will be multiplied by this x minus 2. Open the brackets, you get 6x plus 3 minus 5x, minus and minus 10 positive, and then 5 twos are 10 over the denominator as it is. 6x minus 5x x, 10 plus 3 is 13. So x plus 13 over x minus 2 into 2x plus 1. So this will be your final answer. Question number 25. OABC and OPQR are parallelograms. A is a point on OP. C is a point on OR. This is A. This is vector C. OA ratio OP is 1:4. So OA is 1 parts and OP is this full vector. It is 4 parts. OC ratio CR. OC ratio CR. OC is 2 parts. CR is 3 parts. Part A is find OR in terms of C. OR in terms of C. So OR will be, if you look at this ratio, this is 2 parts, this is 3 parts. This full vector OR will be 5 parts, 3 plus 2. So if I look at the ratio, let's look at the ratio OR ratio OC. OR is 5, OC is ratio 2. So if I write it down as a fraction, OR over OC is 5 over 2. This gives me OR is 5 by 2 times OC. And what is OC? OC is C, so this becomes 5 over 2C. So in terms of C, OR is 5 over 2C. Find CQ as simply as possible in terms of A and C. So CQ is this. If I use head to tail rule, CR plus RQ. So CQ is CR plus RQ. Now what is CR? You're given this ratio. If I write down this ratio as a fraction, I'm writing it in the opposite way. CR in the numerator over OC. CR is 2, OC is 3. So CR is what? 2 by 3 OC. And OC is C, 2 by 3C. So I can write CR here, 2 by 3C plus what is RQ? Since this is a parallelogram, RQ will be the same as OP. And OP is what? 4 times OA, 1:4. So if this is A, this full vector will be 4A. And if you want to write it down and calculate it, I can do that as well. So let's write down this OP over OP over OA. What is the ratio? OP is 4, OA is 1 over 1. 4 over 1 is basically 4. And this gives me OP equals to 4 times OA. And OA is simply A. So OP equals to 4A. So OP is the same as RQ because this is a parallelogram. So RQ will be the same 4A. So this is 2 by 3C plus 4A. 2 by 3C plus 4A. Find the ratio area of OABC over area of OPQR. So area OABC over area OPQR. This is the ratio that you want to find. OABC is this small parallelogram and the other one OPQR is this larger parallelogram. So since you are only interested in the ratio of the areas, I can simply take the two sides and multiply them to get the area for both the parallelograms. Since this is ratio, that is fine. If you have to actually calculate the area of any parallelogram, then you use the perpendicular height. But in this case, we can use the slanted height as well. So the area of this smaller parallelogram will be this A times C. So AC. What is the area of the other parallelograms? We calculated this RQ side or OP side was 4A multiplied by this OR. OR was 5 by 2C. So 4A times 5 by 2C. So AC, 2 times 1, 2 times 2, 5 2s are 10. 10 AC, AC and AC cancel out. So 1 over 10 is the ratio area of OABC over area of OPQR. So 1:10. So this was the last question of this paper.